Okay, today we're going to be learning about continuity. So for a graph to be continuous at a certain point that we'll call C for this, it has to follow these three rules. 1, f of c must exist. 2, limit of f of x as x approaches c must exist. And 3, the limit of f of x as x approaches c must be equal to f of c. Now, once you're actually good with continuity, you can just skip these two steps because basically 3 is all that matters later on. But anyways, let's do examples for rule number 1. F of c must exist. So in this graph, does c exist? F of c exist? As you can see, it's an open dot, so it definitely does not exist. Therefore, rule number 1 fails. So in order for it to pass rule number 1, it must be a closed dot. Well, it doesn't have to, well, yeah. Anyway, so for example number 2, the limit of x must exist as x approaches c. So as you can see, it passes rule number 1 because f of c does exist at this point. But does the limit exist? In this situation, as you can see, from the left and the right sides, they're approaching different numbers, so there is no real limit at this point. So number 2 fails. So for example number 3, limit of f of x as x approaches c has to equal f of c. And in this situation, in this example, even though it passes rule number 1 because f of c does exist at this point, and there is indeed a limit, which is here, the limit, which is this, and the open dot, and the actual f of c are clearly different, and so rule number 3 is not passed. So these two have to be equivalent in order for 3 to be passed. So these are the rules that must be met, or conditions that must be met in order for a graph to be continuous at a point. So here's Dennis to give you some examples.
Alright, thanks Milton.
You're welcome.
So during this part of the video, we're going to be going over some harder examples that you might see in your own calculus tests about continuity. Now, is this graph continuous? Well, whenever you're asked this question, go back to the 3 rules that Milton went over. Does f of c exist at this point c? In this case, f of c does exist. It's over here. So, put a check mark. Does the limit of f of x as x approach c exist? Well, in this case it doesn't, because as you approach it from the left, the value is here, but as you approach it from the right, it's here. So this doesn't. Therefore, if there is no limit of f of x as x approaches c, they can't exist. Therefore, we conclude that this graph is not continuous.
I see.
Now let's look at a different graph. Does f of c exist on this parabola? It does not. But does the limit exist? It does. Though it passes one of the rules, since it doesn't pass all 3, in this graph, it is not continuous. Now, is this graph continuous? Don't be fooled. Though it looks like a typical absolute value graph, because of this point, f of c does exist, and the limit exists. However, because the limit here does not equal the actual value of f of c, it is technically not continuous. Now let's take a typical sine graph, for example. And we'll mark this point as C. Does f of c exist? In this case, it does. Does the limit of f of x as x approaches c exist? Well, the values the limit approaches from the left and the values the limit approaches from the right are the same, so it's safe to say that the limit here does exist. Now, does the limit of f of x as x approaches c and f of c exist? I think it does. So unlike our past three examples, in this one we can see that f of x as x approaches c equals f of c, therefore it's continuous. Now these are a lot of rules to remember, so let's look at a general way to test for continuity. My favorite, the pencil line test. If you can draw your graph without once taking your pencil off the graph, then it is continuous. If for some reason, when you're drawing your graph, you have to lift your pencil and then continue, or lift your pencil, draw another dot and continue, then 99 times out of 100, your graph will not be continuous. Thank you for watching our video about continuity.
And one case where it does not pass the pencil line test, wait, it passes and yet it's still not continuous is this. Well, it's just like, oh, you didn't lift. But basically, it's not continuous even though you didn't lift your pencil. But basically, most of the time, the pencil line test works. Thank you, Dennis. Yeah.